This is a video on conditional probability. By the end of the video, you should be able to find the probability of an event given the occurrence of another event. Conditional probability is the probability of an event A happening given that event B has happened. We find this by the quotient of the probability of A and B happening divided by the probability of B happening. Let's take a look at a first example in which a table provides some information about the hurricanes that developed in the eastern Pacific Atlantic Oceans from 1997 to 2003. We want to find the probability that a hurricane during this time period is an Atlantic hurricane given that it is a Category 3 or greater. So to do this, we see that the total number of hurricanes is 103, and that the probability of both events happening, now let's consider what the two events are. Those would be that we have a hurricane during this time period that is Atlantic and being Category 3 or greater. So those are the two situations. So for instance, here if we look at Atlantic hurricanes that are Category 3 or greater, that's this, and the probability of that happening, so the probability of A and B happening, that would be 21 out of the entire 103. Now, the probability of B happening, that is just that it is a Category 3 or greater. So the probability of B happening, that's going to be 45, that's all of these, the 24 and 21. So that's 45 out of the 103 hurricanes. So now we find the quotient of these. So I have my 21 out of 103 divided by 45 out of 103. That comes out to a ratio of 21 to 45. That is the probability of A given B happening, or in this specific case, the probability of an Atlantic hurricane given that it is a Category 3 or greater. For our next example, let's think about Andrew tossing two dice. What is the probability that he tosses two even numbers, so that is event A, given that he has tossed at least one even, that is event B? Now, here's an interesting thing here. The probability of A and B happening, which we need for the numerator of this probability problem, that probability is the same as the probability of event A happening. The reason for that is that if we roll two even numbers, that means at least one is even. So by A happening, we have already made sure that B is happening. So the probability of A and B, or just the probability of A, can be thought of as this. The number of ways that that can happen would be 3 by 3. There are 3 even numbers on the first die by 3 on the second die, out of 6 by 6, because there are 6 numbers on the first die by 6 numbers on the second die. So that gives us 9 out of 36. Now, for the probability of just B happening, probability of B. Well, to figure that, it's probably easiest to just think of the probability of rolling anything, so the entire probability, which would be 36 possibilities out of 36, take away the possibility of rolling two odds, so that would be 9 out of 36, the same as rolling 2 evens. So this is all the possibilities. This is the possibility for rolling 2 odds. Same as rolling 2 evens we found out before. What that does, if I take out where the situation with rolling 2 odds, then regardless, the leftovers would either be no odds being rolled or only one being rolled. Either way, if no odds are rolled or one is rolled, I know that at least one is going to be even of what's left over. So either one would be even or both would be even. So that leaves me with 27 out of 36. So now, the probability of A happening given B would be 9 out of 36 divided by 27 out of 36, which simplifies to 9 out of 36 times 36 out of 27, which is 9 out of 27, which is 1 out of 3. For our next example, let's think about a student that is about to take a 4-question true-false quiz. If the questions were selected at random by a test generator, what is the probability that 3 of the questions have an answer of true and 1 having an answer of false? So 3 having an answer of true and 1 having an answer of false, that is condition A. Condition B would event B, would be that the answer to the second question is true. So when we look at that, for A, there are 4 out of the 16 possibilities in the sample size. So this is the sample set right here. Okay, 4 of those have 3 true and 1 false. I have those in this second row here. Those are all of those possibilities. So the probability of event A happening is going to be 4 out of the 16. However, the probability of A and B, so that is that the 3 questions are true, but that the second question is true, is only 3 out of 16. And the reason for that is that I now need to exclude this event where the second question is false. Now, for the probability of B happening, probability of B where the second question is true, that happens 8 times out of the 16. So now, the probability of A given B will be the ratio of 3/16 to 8/16, which then simplifies to 3 out of 8. For our last example, let's think about a situation where 2 dice are tossed one at a time. The results of each throw are recorded on a piece of paper to form a 2-digit number. For example, if a person rolls a 2 with the first die and then a 4 with the second die, the number 24 is recorded. What is the probability that a 2-digit number recorded ends in a 5 given that it's odd? So ends in a 5 is A. Given that it's odd is B. Now this is an interesting situation because all the possibilities where it is ends in a 5, such as 1, 5, 15, 2 with a 5, 25, 3 with a 5, which is 35, obviously, 4, 5, 5, 5, and 6, 5. Those are all odd numbers. So in this case, the probability of A is again equal to the probability of A and B happening. Okay? So the probability of A, or the probability of A and B happening, in this case, is 6 events out of a total of 6 by 6, which is 36 possible rolls. Now, the probability of B happening, how many odd numbers could be rolled? Well, when looking at the sample set, half of the numbers being rolled could be odd. So that will be 18 out of the 36 numbers. So now the probability of A given B will be 6 out of 36 divided by 18 out of 36. That simplifies to 6 out of 18, or 1/3, 1 out of 3. Good luck, have fun, I hope this helps.